The Insider's Guide to Energy podcast is proud to announce the Data Science mini-series in collaboration with Forbes, problem-focused and solution-driven. On this show, we will be covering everything from data science fundamentals to trading, forecasting, working with large datasets, and even skills required. Make sure to follow us on Spotify or Apple Podcasts so you don't miss out on new episodes.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and with me as always in this mini-series is Selena. Selena, welcome back to the program.
Hi, Chris.
I am super excited. We are making progress in our data science mini-series, our energy data science series. We're moving right along. And today we've got another interesting episode coming up.
Oh, yeah. I'm very excited now.
So from your perspective, what do you think we're going to learn today?
Well, I'm hoping to hear a lot about new technology, innovation that helps us going forward. I would love to hear a little bit about time series, about the challenges that come with it, especially when it comes to storing and retrieving the data. And so I'm very excited to hear about all that from our guest.
Well, let's bring our guest on board and start the conversation. Edouard Alligand, welcome to the program.
Hi, Chris. How are you doing?
I am doing fantastic. As you can see, we're excited about the program. We're looking forward to hearing what you have to say. But I think I always start the podcast off this way: is I have a pretty good idea of who you are, and maybe the folks looking at the show notes know who you are, but probably an introduction to who you are professionally is a good place to start.
Sure. So I'm Edouard Alligand, I'm the founder and CEO of Quasar. Quasar is a data platform that is really optimized for large-scale time series processing. And we engage with customers in three different verticals: finance, manufacturing, and telecoms.
So we're an energy podcast. What kind of large data sets are you working on in energy?
Energy is mostly for weather data, electrical waveform data, this kind of thing. So energy is interesting for us because we do two things. We do energy trading, and we do also forecasting based on electrical waveform data for manufacturing.
So I guess so you've described what you're doing. What are the problems that your customers are experiencing, or how are you helping your customers out?
So if you zoom out a lot, what we're trying to do with our customers, and we've been successful with some of them, is what happens if we manage to really increase the resolution and the amount of data we capture, and essentially the data is organized in time series, and we perform a statistical analysis on it to have like an idea of what's going to happen. And in a way, it's not really different from what weather channels are doing, like capturing all this data all around and trying to predict what's going to happen. So you can do that obviously in energy trading, like you're trying to figure out what is going to be the trend of the market. You can also do that in manufacturing, trying to understand what is going to happen in your factory. Is there going to be any failure? Is there anything going to happen? And what we're doing, and the crazy idea of Quasar, is what if we capture absolutely everything? What if we just store everything? Is it technically possible? Well, yes, it is. And is there any gain? And yes, it seems there is a gain to do that.
I would like to hear just some more about your company because you've been around for a couple of years. Maybe you can explain something about the beginnings and about the thoughts that went into the focus of your company. Just going about those big data or large data use cases that you were talking about.
Yeah. So initially, the company was started in 2014. So that's almost 8 years now, or 9 years. And so we got started on the risk analysis problem in equity derivatives. And we were trying to build, I mean, it was around was the end of financial crisis. And it was a real need to be better understanding risks. And so we created this platform, and then we branched out in different financial use cases, and then in manufacturing, and then in telecoms. Everywhere where you have a lot of data and where there is value in analyzing this data. And we built the platform from the ground up. So was it a good idea? Was it a bit crazy? What, I don't know. Well, the company is doing pretty well now, but it was really the idea. We At that time, if you remember, it was really all about Hadoop and all of these platforms and NoSQL. And my hunch was, no, this is not going to work. This is not the right approach. What we need is a system that is neither a data warehouse nor a data lake, and that is really tailored for this high volume numerical data. And that is what Quasar is. Initially, it was only a database, but now it also takes care of ingestion, and it can do also some sort of analysis in AI.
And your approach is to capture absolutely everything. Just to-
Yes, all your data belong to us. But the so to be clear, the customer owns the data. The Quasar is the software platform. They own the data. Um, we think there is no, especially with compression, we managed to make it possible. For example, a very good example is electrical waveform data. So you know that electricity is a waveform, and you can sensor capture the waveform, and you can actually capture the full waveform, and it has a lot of information, as opposed if you just capture every minute. You can really get powerful insights. And we think it's the same for energy trading, like especially with renewable coming up. Being able to capture absolutely as much as weather information is going to make you better at predicting prices or computing a price. And sometimes on the market, you just need to be a couple of percent better than the competition to be just the winner.
Yeah, so we have seen, especially in the energy, like this changing landscape with renewables coming in, and you already touched upon that, that the data is growing and growing. So how has your concept evolved with this changing landscapes in energy?
So that's great because what we've seen is we've seen successful companies in energy trading that had an infrastructure in place, and that infrastructure required only maybe one update per day because they needed certain closure price to like give their customers a price. Hey, how much are you going to charge me? Because the problem with energy, you cannot store it. I mean, if we're talking electricity, for example. So they're like, hey, how are you going to charge me if I want to buy electricity? And they were doing very well. And but suddenly, as with renewable getting in the energy mix, there is a lot of volatility and variability introducing in the model, and suddenly the system they had is has difficulty keeping up with frequent updates. And that's because usually they made the right choice of opting for data warehouse, but data warehouse is not good at frequent updates. So when we come in, usually we manage to fix all the problems like squaring the circle, frequent updates, but that's the at the same time having powerful analysis. And the compromise we've done to do that is to focus on the organization of data as time series.
So I guess what I heard you say so far is you started out as a database, a better database, right? A better scalable database, and you can handle scale. And the problem sets that I heard you say so far are energy trading and weather. Those are two large data sets. And I guess with the scale, what you're saying, is it a protocol for the update that's improved, or how are these updates being more efficient in your system than how it was before you existed?
So that's where I said Quasar started as a database only, like the database engine, and we grew up a bit because we realized you could be significantly better at capture if you can get closer to the data and work with the protocol and the data capture as soon as possible. So then you can optimize the transfer between your source and the database system. And to do that, however, you need to own a little larger piece of the whole system. So usually we start working even at the so if you have like a data event processing like Kinesis of Kafka, we connect directly to it, and we have components that can get inside it to really optimize the transfer. It's really a traditional optimization problem that you have in software is if you just do greedy optimization, like you optimize every component, you can get a good result. But to get the best result, you need to zoom out and look at the whole problem, and then have, I hate that word, I'm going to use it, holistic approach of your data. And so if you can have the components that are aware of each other, then that's how you get the gains.
So what setup do the companies that you're working with your clients need to be able to leverage everything that you talked about and to make most of the data that they have that they're capturing?
So the great news is we are supporting out of the box a bigger and bigger data set. And so I'm going to use an example in crypto because the data sources are very public. But let's say you're a crypto trading firm, we support some exchanges out of the box and can connect you to it and you capture it. Energy trading is not very different. And if you already have a system in place, we already have the plugins. So we either, or solution engineer, or one of our partner is going to come in and do the integration. We like to see ourselves as strategic partners and not just someone who says, hey, here's your subscription, give us your credit card. And because we at the end of the day, people are choosing Quasar to make money or saving money. And we're really trying to focus on that.
I recall in the pre-call what you said was that you don't build custom solutions. Basically, you try to get the users
No,
to use what you
no.
do, right? So you got this database, you got some hooks to get the data in closer. You're working closer and closer to the data. But energy trader A and energy trader B both use the same platform for
Yeah.
competitive advantage.
Yeah, well, no, because there are difference in their strategies. To give you an example, we're like this super premium tool vendors, but that doesn't mean two different entities are going to have the same result. First of all, while they may be trading it against each other, what is going to make the difference is going to be strategies. What Quasar enables them to do is to make sure that strategy are optimal given their understanding of the market. But I'm not going to be able to come to your business and tell you, oh, you should do this. What I'm going to tell you, and I'm going to guarantee you're going to have a good visibility. So, given your knowledge, your strategy, you're going to make the best decision possible. But at the end of the day, what is going to make the difference between two hedge funds is their vision and their strategies, not really like it's they're just not going to make mistakes because they had the wrong data or because they could not execute or refresh the model fast enough. So those problems is what we fix. But yeah, no, I cannot have IDs instead of you. That I cannot do. Or if I have, you should not use them.
Yeah, visibility is something I really want to talk about because when it comes to developing a strategy, we sometimes want to go back in time to test, maybe to do some back testing or to understand the market better. So historical data is very important,
Yep.
and to store historical data in a frequency or in a granularity that is gives us insights. I mean, that's something that's yeah, talking about large data sets. So, what can you tell us about that? How does Quasar help?
So that's you're really like that's the heart of one of our, I think, killer features is Quasar is architecture for two optimizations. The first is speed, the second is cost. If you're talking about storing 1 petabyte of data, let's say in the cloud, if you do that in traditional volume, it's going to cost you a fortune. So Quasar is built-in tiering mechanism where you can use object storage. For example, in AWS, which is one of our partner, we use S3 to store the data, and it's transparent for you, the user. You're not even aware where the data is, but it's compressed and stored in object storage, and we retrieve it automatically for you, and we do the query. So whether you query data from 1 year ago or for 5 minutes ago, the only difference is going to be a cache effect, maybe, but the query is going to be the same. And one thing we've seen when I was working in investment banking, there's a lot of opportunity cost because there is basically one system for the data of today and another system for the data of a couple of days ago. And you have a quant that comes to you and says, hey, I want my data from a year ago. Oh, no problem. I'm going to ask the DBA. Oh, going to have it 1 week ago. Too
Yeah,
late.
2 days
It's
later, 2 weeks
yeah.
later. Hmm.
And I think data system, where we want to go, and obviously not the only one to think, the way the human mind functions when you're trying to think about something is interactivity is super important. So if you can have your result in less than a minute and hopefully less than a second, it's not the same as if you have the data like an hour later, a couple of hours later. In telecoms, we have a couple of use cases like that, where we come in and replace a system where you have answers to the question from 2 weeks, 2 weeks, like to have the answer to a query. So it's like, then you don't query the system, you don't use your data.
So, okay, it's about speed and efficiency. So you have some kind of nearline storage. You go to a cloud for some storage, and you're able to query it quicker with your technology. But then you said the second element is you designed it to be cost effective. Help me understand what my database does to be cost effective.
So what is expensive when you do cloud storage? Actually, cloud is storage. storage is the number one driver of cost in cloud. So how can you optimize this? Well, first there's compression, but obviously we're not the only system with compression. Ours is probably the best. No, it's not the best, one of the best. But then is not only that, but how do you store on the most cost efficient possible at a given point without sacrificing performance? And Quasar has this tiering mechanism where we can move data from different speed of storage depending on how often it's used. And yeah, it can result in significant savings. Like a bill of $1 million a year can become a $100,000 bill in terms of storage.
All right. And so to do that, there there's got to be some prioritization, right? With all computing, right? So usually I've got some stuff in my cache, I get some stuff maybe in my drive, and then I got some stuff maybe in some long-term vault or archive, right? And I pull the stuff in that kind of an order in traditional computing. So you're saying there's something similar in your database structure that allows you to do that, right?
Yeah. And
And
one of our secret sauce is we are aware of the kind of data we're working on. So there are many algorithms. For example, Quasar is heavily optimized for order book data. We typically capture level 3 market data, but we know it's order book data. So we have a way to store it that is efficient. It's not just numbers, it has certain properties. And we know how it's typically queried. So the cache can have a little bit of awareness of to do that. And this kind of optimization adds up a lot. It
so
makes
you
a
pre-populating your cache then, so you're anticipating that if
yeah.
I'm going to do order book data, that's going to be more valuable. So perhaps I keep that in the cache, and then I store other information that's less often queried, maybe.
Yeah, for example, we know what kind of queries you're going to run based on the data you have. So we can optimize storage, pre-populate. We also sometimes know that we should not keep some data in the cache. Cache pollution is a big problem. Um, I mean, caching was one of the most difficult software engineering problem that exists. And solving the general case is near impossible because it means you have literally a crystal ball and you can see the future. But you can cheat by knowing, well, we know those use cases, we know what typically happens and how it works. So you can do optimizations that make a difference. And yeah, at the end of the day, if you talk to your customer, they're like, speed is awesome, you want speed. But again, if my system is going to cost me $5 million of cloud bill a year, it's just, I'm not going to do the project. It's not possible. So you have to be able to bring back down the price significantly to be able to sell the idea of higher data resolution.
I hear there's a lot of optimization and smart workings inside of Quasar, but we know that the clients and the customers also want to do their own computations, algorithms, AI functionality. And when we talked about Quasar in the call, I understood that especially for those functionalities, there's a very yeah good way of making use of the data when using Quasar.
Yeah. So the logic we have is the last mile, and that's a great way to go back to what Chris was saying. But what is the difference between me and another company if we both use Quasar? The last mile is always so specific to the user that we don't think it should happen within our data platform. The goal of Quasar is to give you data that is so refined that the last mile becomes pretty easy for you. Pretty often it happens in pandas or this kind of technology. It can also be like a Spark job if it really needs to be on a lot of data. And then there are ways to make Spark and Quasar work together. But it's important to say we give the best toolbox possible for data to be used for AI, and it's pre-populated. You can pre-aggregate the data or fully aggregate the data, but it's not a generic computing platform.
And does some functionalities that your customers are building in flowing back into your core product? Is there some learning from each other?
Oh yeah, we do that so often. A lot of features, for example, we have for order book processing comes from discussion with our clients. Electrical waveform data is the same. We always are asking ourselves when their customer says, "Oh, it would be great if the system could do that." Like, well, probably there are other users that would love to have that too, and we always learning from our users and customers and how to make the product better. It's an everlasting task.
And then, so you have some intelligence in the platform. You got some learning from the customers. We're talking about AI. There's special hooks that need to be from your platform, or is it just a source going in that, like, are you accelerating the AI or improving the AI? Are you doing anything to make the value proposition more than just the data?
Yeah. So AI is two things for Quasar. First, Quasar itself has a bunch of AI algorithms to optimize the data processing, compression, pre-processing. But it's more about making the data very easy to work with AI and to have a bunch of pre-available algorithms or functions, statistical function. To be clear, when I say AI, I use the word automated intelligence more than artificial intelligence. It's more about automating some know-how into software. And so Quasar is really like that. And it's really also because now people think AI, they think natural language processing, they think chat GPT, but we are more into the realm of numerical data processing and statistical function. A lot of it's beautiful to see that a lot of massive productivity gains we gave to our customer come from very simple function that exists for centuries.
Thinking about hands-on, what APIs or what out-of-the-box connectivities do you deliver with Quasar when I really want to, yeah, picture myself working with the data?
Oh, or number one tool connectivity is definitely Python Pandas. There is a module. It's by far the most used AI data tool that we have seen used by our customers. It's the most in demand. And we've made very sure that all the data that comes from Quasar is directly a data frame. So you already have the data right as a data frame, and you can even ask Quasar to do some of the computation you would do in Pandas for you, which is great. For example, if you want to do big aggregations on data, you don't want to bring all the data in your Python program. And Pandas is definitely the number one tool, and there are other tools. But yeah, you asked me the question right out of the box, tell you Pandas.
Okay. Another question, when I'm thinking about the energy industry and how you said that energy trading is there are many use cases that you're working with, the order book that's native or that's very ingrained in Quasar, but you're also in manufacturing, and I was wondering if there are use cases that you were already working on when it comes to power plants, because I mean that's kind of the nexus between the energy industry and something that's like manufacturing.
So I can't go too much in the specifics, but yes, we're actually working with energy providers into what we're doing. I think I can tell you about one use case that is pretty interesting. Is it's actually pretty hard for energy providers to reliably know when they have like transformers fading. They have a lot of fake alerts, and so they need to dispatch people and there is no problem. So we can help. I mean, the savings are substantial, because you really, when the team is deployed to somewhere where there's no problem, that's a lot of waste for everyone. Then energy is so wide because it's so big. I mean, it could be different if it's a nuclear power plant or if it's renewable energy, if it's but we think we've only barely scratched the surface of what can be done with data processing in general.
Who do you deal with as your customer, right? So you don't make the solution, you make the solution better, right? That's kind of like the old BASF ad, right? They kind of make it better. So you help with the data, you help the accessibility, and help with the scale. Um, who's talking to you? Who's the customer?
Depends on the size of the company. For medium companies, it's very often the C-level people are talking to us. And for a larger company, they usually have like a head of data science, or in finance, it's very often trading desk boss, or we usually the discussion often starts with the business, and then we cooperate with the IT to make it work.
Okay, so let's talk energy trading because you've used two specific use cases. You said there's weather, and we can go down that path, and you said trading, right? And so trading, you talked about order book. We talked about having visibility and making quicker decisions because I have access to more information. So maybe I make a more informed decision. So the head of trading is getting involved into the software decision? Is that who you would interact with?
No. So unless we're talking about a small firm where the head of trading is kind of doing a lot of things, usually they have a product manager that is take care responsible of the software. But the head of trading usually is involved in discussion sometimes because I mean they care about it.
Okay, so you've got some software IT person, a resource saying, "Okay, I've got this obligation to improve my traders' competitive advantage, so getting better information, make better decisions." Um, and is that the sale proposition that they're saying, "Hey, we want to engage you because we realize that we aren't having enough data in our decision process." And when you say that you provide a bigger view, is that why I originally reached out to you?
What happens is very often they're like facing, oh, suddenly we have to integrate weather data into our model.
Okay.
And the existing infrastructure struggle with that. And then they're looking for a solution and they might find us, or we may be able to reach out to them uh, through our network. Or maybe they know another firm that has been successful with us. And then they'd be like, hey, we want to do the same thing.
And then what kind of savings or what kind of competitive advantage? What are the economics of this model? So you said you're not expensive. You said, look, if cloud infrastructure is expensive, so we want to optimize your use of cloud infrastructure. I heard you say that. But if I'm on the trading side, I just want to win big, right? I want to have
Yeah, you want
competitive
alpha.
advantage because that's kind of how we work, right? And so how do you position your savings or economics to the business stakeholder?
So to the business stakeholder, usually, although we offer lower IT cost, it's a very weak proposition to give to a head of trading because it says, compared to what I hope to make, this is nothing. So usually give like the thing is how much alpha is there in being reactive to the market for you? It's a very simple question. Do you think you are going to make more money if you're more reactive to what happens in the market, or if your data is more current, or if your model can be refreshed more often? If you talk to a trader and you tell them what is annoying for you today, says, oh, well, I'll have my price forward curve once a day. I wanted to have it every hour. I want to have it every 10 minutes. And said, what about every second? And then you say, this is the kind of discussion you want to have, but it requires the firm to be at a certain stage of their journey because maybe they're not even there, which is fine. Um,
Yeah, I can totally see how the company want to make the next step and kind of just pushing boundaries with their existing infrastructure, and they are looking for new technology to help them to push that boundary to go the next step. The energy industry is maybe not known for being very um, quick or very fast when it comes to technology, but totally when it's needed, they're going the next step. Maybe you can tell us more about how the energy industry fits into the picture of different industries when it comes to new technology and going the next step and pushing this boundary.
so that, yeah, energy, yeah, we've been surprised when we've been talking with energy trading firms to see there was a different pace coming from equity. And we thought, well, it's trading and there's a different rhythm, which is fine because energy is a very critical infrastructure. So I mean, people there are much more prudent, and so there's different of pace, but it's going to happen. There is no choice. If you don't upgrade your system, you're going to disappear. That's so eventually everyone is going to catch up with the need to upgrade the system and be more reactive. It doesn't matter if the energy's trade sector is slower than other sectors. Okay, it is, but still, it will need to change.
And the renewable space is changing energy a bit, right? It changes
Yeah.
how often the cycles have seemed to compress. The amount of data seems to be greater, especially if we're going to things that are demand response. It seems like quite a bit of data going in. How is that impacting your business?
We've seen in 2022 a significant rise of requests coming from firms dealing in energy trading. It's not or the majority of our business, and I'm going to look at in 2023 if this trend is going to continue. That's the factual objective data I can share with you. We've seen a significant rise in requests coming from firms that are doing energy trading. And yes, I think you're right. It's probably coming from renewable. And maybe also there is a thing that they all have like like a, you could say a software infrastructure has a duration of 5 to 10 years. At some point you need to refresh your system. So it could be a combination of the two, but I clearly see, I can imagine like a trading desk saying, hey guys, we need to be able to, we are getting murder on the market right now because we are not current, and we're losing because it's very often a zero sum game if you get the deal or not. And so yeah, I can imagine there is some pressure coming from that. We'll see how 2023 goes. There is also other macros elements right now that can also push downward this trend.
Coming back to the weather data, I mean, weather data has so many dimensions to it, so I can totally understand that this is something that really needs new technology in the next level of infrastructure. So, what is your first step when your clients come to you and say, "Hey, this is something we need to incorporate"? It's the time series, of course, that for weather data that's very important. But yeah, there are so many data points and dimensions to it.
So weather data, we have a feature within Quasar, which is also great for other trading assets. Well, it's not trading. Weather data is obviously not a trading asset, but for market data, is we support multiple versions of the same data. So, for example, weather data, there is a use case that is super annoying. Is, for example, you have a forecast, and it says, "Oh, tomorrow is going to be 21 degrees," and then it's, "Oh, never mind, it's going to be 20 degrees." But you need the two versions of the data because you need to be able to build. If you do, for example, backtesting, you want to have the data as you thought it was. But then if you're doing other projection, you want to have the data as the most fresh, the freshest version of the data. So we have in essence, weather data has nothing magical to it. It's like a pretty standard time series, but we have features in the product that make it easier to incorporate it. And then the ingestion itself of the weather data, if that was your question, does not pose any specific challenges from a point of view. And my our users hate when we say that. It says, well, it's just data. We can, at the end of the day, it's floating or integers, but it's going to be integrated in time series, and the integration itself rarely is a challenge. It's just the volume. You have to be rigorous. You have to make sure you have a process to ensure the data inside the database is the data you want. But it's true for any kind of data.
Who does the integration typically with your solution? So your software as a service or a platform as a service, I believe.
Yeah, we're a platform as a
Okay,
service.
so platform as a service. So you've talked about all kinds of interesting use cases. How does an energy trader or an energy provider go about integrating with you today?
Two ways. One, we one of our solutions team is going to take care of it. But our favorite way is one of our integration partner is going to take care of it. And we have integration partners in Europe, in the US, that are happy to help our customers be successful.
And
And
then
sometimes it can also be, it's always in cooperation with the teams of the user, but it really depends.
where is the industry along the acceptance of this technology, right? So as Selena had mentioned, the energy industry, in my experience, tends to be a bit slower than other financials and other industries. Having said that, though, when it comes to trading, that there's money involved and people tend to be pretty adaptive when there's money involved. Um, where is the industry today? And where do you think this acceptance of this kind of technology goes over the next 12, 24 months?
Oh, we are still very early. So the next 12 months, I'm not going to be super optimistic for macroeconomical reasons. But for the next 3 years, it's going to, I mean, when people realize the gains in the product, and we're not the only one offering solution for that, obviously, is going to, the difference between a company that is efficient with their data and one who's not is going to be, it's as if I use this analogy. It's like, when computers arrived in the business industry, like you had like microcomputers, not minute mining computers. They were early adopters, and when they realized the gains of having it, then it spreads. So we are still in this curve where it's like this, but at some point there's going to be an inflection point. It could be very well in the next 2 3 years. Now that the AI hype is a little bit behind us, there we're going to get into this phase of people look at the real benefits.
Is my takeaway correct when I say that the biggest impact for your clients is with intraday tasks, not so end of day tasks, but when it really comes to the speed, as we talked about, everything you want to query or you want to go back, you want to learn some from the data, you want to do that now. So that's more interesting.
Yeah, you're correct. It's intraday task and research tasks. So end of the day, you can always hack around a solution like, oh, I need at 5 p.m. every day when the market closes. I need data, and then you can make it work. Maybe not super efficient or beautiful, but there's always a way. But for more interactive use, that's where it's harder.
What are you displacing? So if I go with your platform, what technology is legacy and no longer exciting anymore? So
So I won't
what are
name
we
anyone.
upgrading?
There is one company we are displacing very often, but actually sometimes we're displacing a bunch like a
So it's like an
Google or
SAP or an
machine.
Oracle type of thing you're talking about, or is this something different?
Uh, Data warehousing is sometimes overused. There has been an overusage of relational database for this kind of use cases, like in data warehouse, like people put everything in data. And not to be clear, great technology. I'm not saying data warehouses are useless or whatever, but no, you cannot use them for everything. They're not designed for frequent updates. They're more like analytical workloads. But we are displacing very often. What we've seen the most is like a collection of open source tools put together to create some sort of platform, and usually it does not produce results. I can name a bunch of data warehouse product we typically replace, like Redshift, uh, which is a great product in itself. There's nothing wrong with Redshift, but if you use Redshift to do training intraday tasks, you're going to suffer.
Cool.
The cost is also a problem. Like for example, if you there's some other famous um, data warehouses, but then you realize you're charged by use, and that's can be a problem.
All right. So it's an efficiency, it's a cost savings, and you see the world's shifting. You think there's competitors in the space to what you do, so you're not the only game in town. Um, and so is the industry past early movers? You described that technology curve, and you showed the inflection point. So we're past early movers at this point. Are we at mainstream users or laggards? Where are we in the technology?
Um, so we're not yet at we are still early, and what is specific to Quasar is we're more the high end of the market. So, for example, we have OEM agreements with certain companies. We typically engage with customers that have big use case, complicated use case. So there's a whole part of the market I'm not aware of. And so my vision of the market is going to be the vision of someone who engage with people who have big problems and the budget for it.
What have you learned along the way? So you started in 2014. You're not brand new. This isn't your first rodeo. You've done this for some period of time. As a startup guy myself, I know that you always kind of pivot or learn along the way, or had some predisposition of that what you thought the market would be like. So in energy specific, what have you learned once you've got into it that maybe you didn't expect?
I was expecting. I'm trying to give an answer that is not going to be perceived as condescending or pretentious. I was
Makes for better
expecting.
ratings if you want to go that way. Our
Hmm?
audience is not afraid. If you want to be condescending and pretentious, knock yourself out.
No, no. So I was expecting that more would have been done. Like because the gains are obvious, but they're especially energy producer. They're struggling already with extremely like real life problems all the time. And so data science is seen very often as an afterthought. And I think I can see we still have a little bit of evangelization for to do. I have seen big companies like spending a bit of money to say, oh, yeah, we've done a bit of AI, but it was not business driven. It was more driven by innovation groups. And the goal was there. I mean, AI is a tool to make money or save money, and So we're still not there, and it's not energy specific yet.
Mm, for the AI functionality, I would just like to add that I think, from my perspective, and that kind of matches what you just said, we're at the stage of still building the infrastructure and learning about what infrastructure is best, before it can really be, yeah, widely adopted and widely used, using AI functions.
One thing that is in our friend Gartner was saying that I think it's 80% of data lake projects failed. We also come after projects that have been cost a lot of money and produced nothing. For example, people capturing all the data, putting that in data lake, and achieving nothing. So it's sometimes you have to really prove your worth.
But I think that's the wonderful thing about data science, especially if you're a consultant, is there's never an end to the data science project, right? You're always collecting your data and evolving. So it's an interesting world. Do you have, as we get ready to wrap up, is there a use case or a success story that you could share with us? You can change the names to protect the innocent, but is there a story or something where you've made a difference to a company that maybe you could share with our audience?
In manufacturing, we have customers that saved in 1 year $7 million with us.
Okay, but that's not really a use case. That's just the savings. So what specifically did you do to achieve a $7 million savings?
We enable them to be more accurate in the prediction of the potential. So it's in industry where downtime are extremely expensive, like unscheduled downtime of machines. We're talking machines that take a long time to boot. You have workers that have nothing to do because the machine failed. And with Quasar and of course the intelligence of their data science team, they managed to have more accurate models and to be able to anticipate problems better, which resulted. I'm going to give you numbers, a ballpark. I cannot name the customer, but I know that if they have one factory that cannot work for 1 day, it's millions of dollars, and a downtime for a couple of hours can be easily $2 million. So you can get your money back very fast with the system. In trading, it's funny because we know we're successful when we don't hear from our customers that just renew every year. Because even though we have very tight partnerships with some of our customers, they're very secretive about their strategies and exactly what they're doing with Quasar. But yeah,
Well, we were very happy to hear from you. Thank
thank
you so much, Edouard, for your time and your insights.
thank you.
Thank you for being the show for our audience. I hope you've enjoyed this journey today as much as we have. If you had, please don't forget to share the podcast, subscribe, like us, and add comments. You will get feedback. And we look forward to speaking to you again on another episode of Insider's Guide to Energy, our data analytics series. We'll talk to you soon. Bye bye.